So we have to take into account time value of money, and again the object of this exercise is to determine what the value of S is. Let's go back to our question. Estimate the credit default swap spread. Okay, so we really want to I've messed up here for a second. Okay, let's take that out. We want to estimate the S. Okay, what's the value of S? If the seller contingency payment can be estimated to be a value of 0.05, right? On a $1 notional or €1 notional principal, then what level of S should the buyer be paying the seller so that this credit default swap is a fair exchange or a fair game? Okay, so again, like most swaps, we assume that what's being exchanged is amounts of equal value. Even if the payments are contingency payments, what we anticipate the value of the payment would be should equate. Okay, so if you're paying S, 5S, or you commit to pay 5S, and you're receiving an amount equivalent to, in theory, 0.05 of the 1, that's the value of the protection, then S should reflect the value embedded on from the sell side. So these amounts, if you like, are equivalent. We've worked out in terms of S, the value taking account of survivorship and present values. We've worked out what committing to paying 5S is in economic terms worth, right? So we've worked out that 5S pre-committing to pay 5S when adjusted for survivorship and discounting, that's equal to 4 in present value terms, roughly. In addition, on the buy side, if default does occur, you must pay. We assume that default occurs halfway during the year, so it won't occur at the beginning or the end, but actually occurs in the middle of the year, in the middle of the fourth year, middle of the third year, and so on. That the buy side would also have to pay half of the year's S. So you're pre-committing to pay 5S, but let's say in the event of default in year 3, okay, so we come down 1, 2, 3, so that would be 2.5 years in, we would pay half. The value of what we would pay, again, should be half. So I should change that to 0.5, in fact, 0.5. I pull that down. Why is it 0.5? It's 0.5 because we're saying you would pay half that amount. You're adjusting for the fact that you're paying only half a year's S. Okay, you're paying half a year's S, but probability of default would be 0.196, and you're paying half of that. Okay, and we pull it down. Okay, and then we must generate the discount factor. Now let's check our discount factor. It's equivalent to month 6 discounted at 5%. Discount factor 0.975. Again, we drag that down for 1.5 years at 5%. Discount factor 0.92, 0.88, and so on. Okay, and then at that point we can take the product of the expected accrual times the discount factor. Now again, these can be viewed as S, and maybe I should have made that more explicit. Each of these are equivalent to the product of these two is an S value, right? Now very small, as we can see here, it's clear that it's a very small amount of S, right? It's not 1S, it's not half S, it's 0.009 of an S, so actually very, very small. And again, the probability of this occurring is small, and the probability and the amount involved is small. So again, these S's are small, but we must take them into account because there is an accrual there that must be reflected in the S's that's being paid. So if you like, the buyer pays S, and so in theory, on the buy side, we're paying 4.07 S when we adjust for probability of default and adjust or survivorship and discounting. But in addition, in the event of a default, the buyer must pay half a year's S. So, and the probability of S in year 1 would be 0.02. Half of that would be 1. And then when we apply discounting to that amount, based on the 5% continuous rate, we get 0.00975 S. Okay, so in addition to the 4.07 S, when we must take into account accrual. So we sum. These should be 5. And we get 0.04. So again, it's a small amount of S, right? So how much S is being paid then in total on the buy side? Buy side payments are equal to this, well, the accruals plus this amount here. Okay, so that's 4.113. I better put it in S. That's the buy side, right? And this on the sell side, the total amount, the value of that payment is equal to 0.0511. Okay, so the product of the 4.11 S is equal to 0.05 of the notional principal of the reference asset. So if we consider the notional principal to be $1, then what the sell side is offering is economically equivalent to 5.11 cent. And the sell side is going to pay, when we adjust for probability of default and so on, and present value of the time value, the seller is, although the buyer is pre-committing to pay 5S, in economic terms they're only going to pay 4.11 S. So what's the value of S? The value of S is just S is equal to 4.11, sorry, 0.05 divided by 4.11. Okay, so the value of S is equal to 0.01. In other words, the spread on the credit default swap should be equal to 1.24% the value of the reference asset. right? The reference asset being what the protection is based on. Okay, so to recap, let's go back to our original question. Suppose the risk-free zero curve is flat at 5%, so that's our term structure. And we're assuming that the yield curve remains flat at 5% for 5 years. That's a very arbitrary type condition, but is useful and makes our estimations below convenient. We're also assuming that the default occurs only halfway through the year in a 5-year credit default swap. Again, that's sensible when we looked at the random number generator in Excel, bounded by 0 and 1. If we average out when events will occur, assuming that they occur halfway through the year is plausible. Okay, and we have also embedded in the detail of the question here 40% recovery. Again, that's a figure. It could have been based on historical data on particular type of bond with a particular type of bond rating. Moody's and S&P make those type of estimations under conditions of distress. What's the recovery rate? And then the default itself is 2%. So given this 4 or 5 pieces of information, the question that we're trying to answer here is what would be the appropriate level of S? And S is a spread or a percentage, and it would be percentage of the value of the reference asset. We implicitly have taken that to mean that the notional principal here is $1, and when we worked out the sell side, the value to sell side is 0.0511 of that dollar, or 5.11 cent. And when we adjusted the 5S, they're going to be paid for survivorship and for time value. That's equivalent to the 4.07S and that relatively small number 0.0425 of 1S. And adding those two figures together gives us 4.11S. So if you like, the buyer commits to pay 5, but when adjusted 5S, but when adjusted for present value and survivorship, that translates into being only an accruals. That translates into only a payment really of 4.11S. The seller is going to pay 0.05 when we work out probabilities and recovery rates. If the basis of the swap is we have a fair exchange or a fair game, the 4.11S must be equivalent of the 0.05. So if you like, we have an identity like this, and when solving, and again maybe we should think of this as being multiplied by S. The 4.11 is being multiplied by S, and that's equivalent to 0.05. So what is S equal to? S, if we bring over our 4.11, then we'll divide the 0.05 by the 4.11, and we get a value of 0.0124. In other words, S should be 1.24%, the value of the reference asset. Each year, the buyer should be paying for 1.24% approximately to the credit default swap seller.